Good morning. We're trying to sort out one slide issue. Trying to get those, but they're not the first presentation. So I think we'll just go ahead and get started and try and work that in the background. Let me bring up the slides. Okay, so today we're going to have a short 1 hour virtual interim meeting. Remind everyone that this is taking place under the note well. Please pay attention to your responsibilities under the note well, and please note to participate if you have not checked that out. So this morning we have two presentations that were associated with IETF-114. After that, this slide is changed since discussions on the list Friday. We're going to talk about the hash then sign issue with post-quantum signatures. And then if there's time left, we're going to talk about the a status update on CMP, the two RFCs that are being updated there. So because of the slide issue, we're going to start with the PKCS-12 presentation while we try and sort out the slides for the CMS presentation. Before we go any further, though, of course, we need a note taker. Is anyone willing to do that? Can someone take notes in the chat that you can get to? I'm sorry, the Etherpad that you can get to with the button at the top of the upper right, little pencil and a pad.
Yeah, I can do it, Russ. It's John Gray.
John Gray, thank you so much. I appreciate it, John. All right, let's then move to the first presentation. Dimitri, are you going to be the presenter?
I think Hubert will be the presenter, as the author of the draft.
Okay, Hubert is going to be it. Okay.
Yeah, that was the plan. Can you hear me?
Yes, let me pass you the ability to do the slide control yourself.
Mm-hmm.
Okay, did you get that?
Do
you see at the bottom of the slides, there's just the numbers and then an arrow to move them forward?
Perfect. Okay.
Yes, okay, good. All right,
Good.
I'll mute.
Okay, so hello everybody. I will be talking about the use of PBMac1 in PKCS-12 file format. My name is Hubert Carrier, and I'll be presenting together with Dimitri. We both work at Red Hat in the crypto team. So quickly about PKCS-12. The purpose of the file format is to transfer private keys, certificates, miscellaneous secrets, and extensions. The specification is in RFC 7292. There are a lot of implementations. The primary ones that we are interested in are OpenSSL, NSS, GNU-TLS, but there are also a lot of implementations in Windows, in a lot of hardware implementations, in network appliances, and so on and so forth. More or less interoperable, basically the only interoperable file format that works for both Windows and Linux environments. The file format itself has a very extensive structure, but on the top level, there are technically just three fields: the version, the autosave, which is the list of items which are inside the file, the file itself, and then there is the MAC data, which is working as the integrity protection for the whole file. What's important is that MAC data specifies just the digest that is used for the MAC protection, the salt used for that HMAC derivation, and the iteration count that's used for the key derivation. While some implementations allow omission of the MAC, as the ASN1 specifications here shown does, most of them actually are quite iffy on that. MAC generation itself is specified in Appendix B of the RFC, and there already is a specification that this like when it's used with password, the key derivation is not recommended, and it should be deprecated for new usage. While we already had the RFC being written, the key function, the key derivation function used was deprecated. The problem for us is that this KDF is not FIPS compliant, so it's not possible to create MAC protected PKCS12 files that are FIPS approved. So our intentions, we want to have an up-to-date standard that allows use of new and current derivation functions. We want FIPS compliance. We also want, as far as possible, backwards compatibility, so that those files would be readable, at least partially, by old implementations. And also we want that implementations to be easy to do, since we will need to implement it in multiple libraries, and so the ease of implementation is important. So the proposal we want to do is to preserve the existing high-level PKCS12 structure, and additionally permit the use of the ID PBMAC1 object identifier as a valid type for the digest algorithm. So instead of specifying as a hash algorithm, it would specify just the PBMAC1 as the hash itself. Then we could use the parameter field to store the PBMAC1 params, and then those would include the information about like how to calculate the HMAC. The HMAC itself would still be calculated according to the PBMAC1 standard, which is specified in RFC 18. While for the PKCS12 structure itself, the MAC salt and iteration values would be completely ignored, since those are, while they make sense for use with PBKDF2, they don't make sense for script or for Argon2. Like those use much more advanced and more complex parameters to work. So we would need to completely ignore them to make for interoperability. The upsides for this proposal is that PBMAC is quite easy to implement, uses exactly the same key derivation functions as already deployed bulk encryption ciphers. So like if you support AES in PKCS12, you already have all the plumbing necessary to also support PBMAC1. The HMAC calculation itself is exactly the same as in PKCS12, just the key derivation for that HMAC changes. We also already have a very widely deployed implementations that will be able to extract the private keys and certificates from files that use PBMAC1 just by telling them to skip the MAC verification. So you can use OpenSSL, probably like even 098 and definitely 101. That's the one, oldest one I've actually tested. That will allow you to read the file by specifying just to OpenSSL, ignore MAC verification, and then you'll be able to verify, like extract the private keys and certificates. Finally, it does provide a very clean upgrade path for modern KDFs. You can, as we specify with the specification already we proposed, you can use a script, and Argon 2 just needs the ASN1 OID specification and parameter specification to be usable there too. Now, the alternative that was proposed on the mailing list was to use AES CCM. Now, the problems are that I'm not aware of any implementation of that inside PKCS 12. None of the widely deployed libraries that we actually use are supported. So none of the OpenSSL, GNU TLSs, Java, Windows Windows implementation, I'm not aware of them supporting them. That would also be the very first AED cipher in PKCS 12, so that would require very new and potentially complex code. This is also not a widely used cipher, so anyone that would want to use it in PKCS 12 would need to implement it, verify, and in some cases also certify. Since we want FIPS certification, that would that for some implementations that would require another cipher to certify. Finally, there is no clean way to handle AES CCM together with HMAC. If we leave in the legacy MAC in the file, then the strict FIP compliance will be problematic, since then you cannot derive the keys necessary for HMAC. Well, if you omit MAC, then you will lose the whole file consistency integrity protection. And for some implementations, that is problematic. Like, they don't provide the APIs necessary for telling the to tell the library to skip the MAC verification. So the specification is on data tracker. It's the draft Cario PKCS 12 PBMac1. There is GitHub also with the source code for that. We have a quick and dirty implementation of OpenSSL in OpenSSL. If the draft is actually adopted by the work group, we will provide a full implementation for OpenSSL. GNU TLS and NSS, that's the absolute minimum. We also will be pushing for OpenJDK support. If you would like to look at the file itself, you can download it also from GitHub, and the password is 1234. Okay, so questions. So first question is from Tim Holbeek. Sorry if I'm mispronouncing. The FIPS compliance problem is the use of obsolete algorithms. Correct. The problem is that the key derivation function is not approved for FIPS use, and we want to use PBKTF2 for the key derivation function so that it's FIPS compliant.
So my misunderstanding is a little bit because, I mean, higher level things like KDFs are usually not in FIPS. FIPS is usually about just the crypto, the individual crypto primitive.
That's old FIPS. If we are talking about 140-2 and current requirements, key derivation functions are very much in scope for FIPS.
Oh, you're right. Sorry. I just see so many people implementing them on top of it.
Yeah, and they won't be FIPS compliant with us.
Yeah.
So my gut reaction, this is Russ, is that your first proposal makes more sense than the alternate, and I'd like to know whether other people feel the same.
Do you mean the first proposal is using PBMac? Sorry for unclarity.
in the slides, you had our preferred way forward, and then you talked about other ways forward. And I'm saying, I think your preferred way forward made sense.
Okay.
And I wanted to know if others thought differently.
Yeah,
John, go ahead.
yeah, I was just going to say, yeah, I agree with that, the first proposal, because the AAD, the cipher, obviously there would be change in the structure of PKCS 12, which I think part of the purpose of it is backwards compatibility and stuff. Plus, you know, the FIPS compliance is a good plus on this, because obviously lots of people need to use FIPS. So I think the recommendation of the first one makes sense to have PBMac1. Plus, we have another, like we put it in CMP as well, and other of our protocols that we work on. So I think it makes perfect sense to do this in PKCS 12.
Okay, Sean.
1, 2, 3, waiting for it to work. Yeah, I agree. Definitely option 1.
Okay, Mike.
Audio
Go
check.
ahead, Mike.
Audio check.
Yep, we hear you.
I think I'm going to say the same thing that my colleague John just did, which is PBMac1 keeps this aligned with the changes we're doing in CMP. So PBMac1 would be good for both CMP and P12. I think that's aligned.
All right, I'm not hearing anyone speak against that approach. My quick skim of the internet draft was that's the only one that's in it. Is that correct?
Only what?
That's the only alternative you wrote down in the internet draft.
Yeah, in the internet draft, there is just PBMac1.
Good, okay. So would anyone at this point speak against working group adoption of this draft? No one is coming to the mic, so I didn't see anything over in chat. So we'll have a call for adoption. I have to say we're IETF 114 put a long list of documents to be called for adoption. We'll add this one to the end of that list, and so it'll probably be a couple weeks till we actually do the call, but we will do that. Any further questions on this one? All right, then we will move to the PQ-SIGs draft in CMS.
Okay, thanks, Russ. Can you hear me?
I can hear you, and I'm passing to.
Okay. Thank you. So yes, so this slide set is just an update of the previous presentation that was done maybe 6 months ago or something like that. So yes, we can just go through the slides. So it's basically the idea. I will remind the idea of the main idea of the RSC. So the purpose is to propose a solution to communicate a key individually encrypted to several entities. So actually, if you can just go further in the slides, please.
I think you have control.
Ah,
Do you
okay.
not?
Okay, sorry.
Okay.
Thanks. Okay, it's Perfect. So yes, so that was the purpose of the RFC, just to define a new mechanism to send a key to several entities and to encrypt the key individually. So basically, the idea is to propose a combination of three algorithms that will be used for encryption. The first is a KEM, a key encapsulation mechanism, then a KDF, and finally a wrapping algorithm. So basically, the algorithm is defined in this slide. So we will first generate a ciphertext and a shared secret thanks to the KEM algorithm, then derive the shared secret thanks to the KDF, and finally use the key encryption key obtained from the KDF as the encryption key for a symmetric algorithm, the wrapping algorithm that will bring then confidentiality and integrity. And so the decryption mechanism is described here. So it's the opposite. So it works obviously. And so in CMS, we propose to use the recipient info type and to set it to a key trans recipient info, and to set the following values in the key trans recipient info. We will set the algorithm to OID IDChem trans, which will be the chem trans mechanism, and then set the algorithm parameters of type generic hybrid parameters. Well, that's it basically. And so I just made a few updates according to the comments made during last meeting. So especially there was a discussion about the KDF, which can be useless if the KEM, for instance, outputs a key of the correct size to feed the symmetric algorithm. So in the RSC, I really clarified that this KDF can be the identity algorithm if we want to skip it. And the other update was to make sure that this RFC proposal is aligned with the RFC 9180, which describes the hybrid encryption mechanisms. So basically, it's the same principle which is proposed in this RFC, meaning that it's a combination of the three algorithm, KEM, KDF, and symmetric algorithm. So basically, the RFC is correctly aligned. And finally, in the RFC, there are still some open questions that have to be answered. Well, but where I'm really open to discussion. So it's about the way to communicate the info. So in this RFC, we suggest to use the key trans recipient info, but well, we could imagine different solutions just to avoid updates of RFCs. Then some open parts are still left dealing with the certificates, especially because it depends on the work that will be done on the PQC PKIX. And finally, maybe some algorithm limitations should be put in the RFC, especially dealing with the choice of KEM. For instance, do we only specify the Kyber algorithm, or shall we extend this use to any KEM? Maybe that's up to discussions. And as well for the choice of KDF, of the wrap algorithm, should we limit them, or should we be, quite open on the choice of the KDF. Should we use SHA-free or KDF based, or maybe that's still open. So if you have any suggestion, I will be glad to get them and incorporate them into the RFC. So that's it for this update. So please, if you have any questions, suggestion, please.
So I think we talked in about keeping alignment with the RSA chem was advisable, but to do something different if there were properties that Kyber, we didn't know that which one would be picked, supported. But I wonder if we would be better served by defining OIDs for triples that had Kyber, which KDF, and which wrap as opposed to splitting those out. Have you thought about that?
Yes, but we think that the combination can make the number of IDs really huge. So that's the reason why we propose to clearly split the combination into 3 algorithms.
Okay, Sean, go ahead.
I'm just going to say that based on your request for input, I would probably just do Kyber and all 3, whatever strengths, whatever they're called, 2, 4, and 5, or whatever it is. I can't remember the numbers, and limit it to that, and not try to make your combinatorics problem more difficult than it really is. But again, I'm not a cryptographer, so I'm just throwing it out there from like, let's not make this too complicated. We're going to have enough of these. Less options is maybe better.
Yeah, I agree. But the only point is, that in the NIST competition, there is a new round that has been opened for key encapsulation mechanism. So maybe for the time being, it's Kyber, but maybe in a few years it could be changed or at least update or enhanced. So maybe that's quite.
Yeah, I think I definitely don't want to get out ahead of our skis, as some people would say, to be specifying things in advance of what NIST has picked. So I would just go with the ones that have been actually selected, and then when they come around, if they pick another version with 2 or 4 or just one other one, then we can update the specification to do that. There's not supposed to be that much to do to spin out a new internet draft and update an RFC. So I think that's probably the better approach, at least in my mind, at least.
I would also observe that if we take the approach where we're using key trans, then all you're doing is specifying the conventions for using Kyber at the 3 levels. And so when another one comes along, we can write a similar one that specifies the conventions for using that one with key trans. Go ahead, Yuri.
First, I think there is some confusion because NIST doesn't open 4th round for the key encapsulation mechanisms. Maybe unless there is a breakthrough and something with many times smaller key size and adequate performance comes up, which is rather unexpected. So we can probably assume that key encapsulation mechanism remains what's selected, specifically Kyber. We can also expect, I think, that if, in the unlikely case, there is a new chem, it will satisfy the same constraints strength-wise. And of course, it is necessary to document those requirements to CAM regardless of whether we decide to stay with the NIST selection, which makes sense, or go outside. Thus, the open question is what to do with a KDF. On the chat, the argument is that one of the reasons to use KDF is to deal with the key size mismatch, with symmetric key size mismatch. That's a valid argument. I do not think we need KDF for strength. I would not argue for using it for size matching. Though, again, I find it rather expensive. Over.
Any response to that? Okay, Mike?
Mike. This is Mike.
Go ahead,
Yeah.
Mike.
Put myself the response to Yuri in chat. So yeah, the KDF was there, I think, super conservatively in case, people end up wanting to put non-NIST chems here that don't have that property that you can just use their shared secret directly as a symmetric key. There have in the past been chems that didn't have that property. I suppose if we're going to be sticking to the NIST chems, then maybe we do get to just assume that property, and maybe the design problem becomes simpler. And then, yeah, as Yuri said, the size mismatch, we didn't want implementers to have to worry about choosing a chem that lines up with the key size of the wrap. So the KDF sort of makes that go away. But I guess if Russ is suggesting that we pick triples, chem KDF wrap, maybe we could actually reduce that down to doubles and just specify chem wrap if we choose ones that happen to have the same size. And maybe that just makes everything clean. Over.
Or even chem and at least key wrap, key size, right? Just a thought. I mean, I need to think it through some more, but the slides made me ask that question. Go ahead, Yuri.
I wanted to say that the old chems that did not have the necessary properties probably shouldn't be considered here. Hopefully we learned something since. And second, making the requirements explicit would easily deal with this issue. You would just look at the hash, for example, and say, wait a bit, we require hash that does not have obvious collisions. This hash has, therefore it is not acceptable. It should be simple enough. Likewise, with chem, with document requirements, if a new chem comes for consideration and we see that it does not satisfy some of the documented requirements, that's just not an acceptable chem. And why should it be? Over.
Mike, your hand is up. Is it a new one or an old one? Thank you. Quinn? Go ahead. Quinn, we're not hearing you, so I don't know what's going on. Can you maybe ask your question in chat? There you go. Go ahead, Quinn.
Oh, I'm sorry. I didn't know that I got to click on the thing. I have a few comments or questions. The first one is regarding to the share secret K in KyberCam. So the first option is to make the K 256 bits for all 2 or 3 chem options, or on this could or we could make the length of K depending on the strength that we're targeting. For example, if level 1 we're thinking about AES 128, so we could make the chem only 128 bits. Or as you said, so there are 2 options there. And a second comment is that regarding to the choice of the KDF, as Mike pointed out, in the future, if we wanted to use a different chem, which which does not have a KDF in the chem itself, then of course we would need a KDF to improve security of the chem outputs. So there's a reason for the chem there. But if like the second choice I just mentioned, where we output the chem size, it is exactly the size that the algorithm needs, like 120 bits of AES 128. So there are 2 choices there. I don't know which way is the right way to go. And the third one is to go to the choice of wrap. I'm not sure if I get all the understanding the need for the wrap here, because with the chem alone, basically you can both sides can get the shared secret key without needing a wrap.
Yes.
The thing is the recipients must do a decryption, the PKA decryption, and then a PKA encryption to check to make sure the legitimate ciphertext were received. There is a chance of failure, but that failure probability is extremely low, like 2 to the minus 150 or something like that. It's like it's practically 0. So so I'm not sure if we still want to have a wrap in there or not.
Just yes, if I can answer. Yes, to me, the wrap algorithm is absolutely needed because the chem outputs a random key. But in our case, we want to send a fixed key because we want to send the same key to several endpoints. That's why we need to master actually the key to be sent.
All right. I just forgot about that point. Thank you.
Okay. I would propose that we do a call for adoption of this work. Is there anyone who would like to speak against doing that? Okay, thank you. We will add this to the list of documents we're doing call for adoptions for. Thank you so much. Next up, Mike, is going to be your presentation on hash, then sign. Let me get the slides up.
So Sound check.
Okay, and you should have slide control now.
Many pop-ups. Okay, I'll try and keep this brief so that Hendrik has time to speak about the CMP updates are more urgent. Briefly, this is a landmine that we discovered in the PQC, the Sphinx Dilithium Falcon. We sort of stumbled into this landmine a couple weeks ago. I know we're not the first people to stumble into it, but we decided to make noise about it. So this is just a PSA talk to get it on our collective awarenesses so we can start thinking about this. So hash then sign, this is a pattern. It's used a lot. And RSA required you to pre-hash. This pattern is pretty well baked into a lot of stuff where what you're sending to your crypto module to sign is a short message. You're not sending the entire plain text. And there's lots of good engineering reasons to do that. Like, for example, if you're signing an email, you could have a 25 meg email with attachments. And if you're signing that with a smart card, you don't really want to stream the entire 25 megs to your smart card. And I put a few examples here. I mean, Network HSM's similar example. Latency gets weird if the HSM is processing variable size messages, blah, blah, blah. And I put Golang here as an example just to show how sort of ubiquitous this is. The ECDSA interface in the crypto layer expects a digest, and that digest is currently performed at the X509 or TLS or what have you layers. Like, this is just sort of making the point, this is a very well established pattern. This pattern does not work with the three signature schemes that we're looking at, Sphinx, Dilithium, Falcon. It does not work because each of these algorithms internally begins with a message digest step that is prefixed with a nonce. And in the case of randomized Sphinx and Falcon, that nonce prefix is a completely random number chosen at signing time. In the case of non-randomized Sphinx and Dilithium, that prefix is derived from the public key of the signer. So TLDR here, you don't want to pre-hash because you're sort of stamping on this hashing that's done as the first internal step of the algorithm. I started a thread on LAMPS and CFRG with a really bad email title last week. And then yesterday, Sunday, I started a thread on the NIST mailing list with a better title. And we've been getting some good responses. And so it seems like the answer is yes, you really don't want to just pre-hash with SHA-256 because you will clobber the security properties here. So my fourth slide here, I think we sort of already have an answer to this given the NIST mailing list discussion this morning. The answer seems to be question one, yes, we do care. Question two, can we safely externalize the hash step of Sphinx, Dilithium, Falcon outside the crypto module? The answer seems to be no, don't do that. And then we're left, I think, the NIST mailing list discussion sort of lining up with our question three here. Chris Pikert said if you want to be sending a short message across the network to your crypto module, then you need to define an envelope layer at the protocol level, which is sort of, I guess, what we were needling at here with number three. So I just want to put this out for general awareness that if we want to support a pre-hashed mode in PKIX where the actual message you're signing is short and compressed and digested, then we're going to need to define that envelope format at the PKIX layer. And we'll need to worry about its security properties, collision resistance, contains a nonce, blah, blah, blah. We'll need to worry about all that at the PKIX layer. That's it. Thought for general awareness. I'll end here.
I would observe that this is just not a PKIX problem, it's a CMS problem as well. But go ahead, Panos.
PKIX in the, yes, sure.
To make a comment. So Mike, thanks for doing that. Thanks for trying to collect the data. I'm not entirely convinced, to be honest, that that the pre-hash fails for all of these cases. I think we should treat it on a per algorithm basis. And in my opinion, I think we should collect all the arguments against it because I'm not sure that what we're hearing so far are practical concerns. There are cryptographic theoretical concerns and there are practical concerns. So, maybe for Falcon there are, but I'm not sure they're for Sphinx and Dilithium. So in my opinion, we should really understand the counter arguments before we embark on the trip. And thank you for doing that. My goal is to try to understand it a little better.
Okay, anyone else want to comment on this? I realize it was a call to action, not a specification to adopt. Okay, Mike, thanks for raising the issue. And we'll move to Henrik.
The call to action here probably is for like Massimo, Jake, and Panos and Sean, your draft that's doing dilithium. Like that's the place this would need to get addressed.
Indeed.
I want to stick a
The
placeholder
lithium
dilithium draft.
and the CMS Sphinx draft as well.
And the
Yeah.
CMS Sphinx draft and the eventual Falcon equivalents. Yeah, I don't know if you want to stick placeholders in now because we're going to need to sort this out one way or another.
Go ahead, Yuri.
I just want to re-emphasize my previous argument. Dependence on collision resistance property of hash. Of course, we expect collision resistance property of the modern hash. And if you insist on using MD4, go elsewhere. Over.
Go ahead, Sean.
I was just going to say thanks for that, Mike. I expect that you'll keep us honest. So appreciate it.
Okay, then we're going to go to Henrik's status.
Yeah, so thanks.
Thank you, Henrik.
Can you hear me?
I hear you.
Okay. Thanks for getting the chance to give a brief update. Just one slide. Early August, the authors of CMP updates, including Mike, prepared the 0.0 version of the 4210 bis and 6712 bis, which is mainly the original RFC text, and then the 0.1 version where we merged the changes specified in CMP updates into the documents, and then we did a review and provided some additional editorial changes, sorting out some things we came across while reading, and added an action item for Appendix C to be reviewed more closely, fixed some nits, and we came across the topic whether this is now a good point in time to also add support for CAM keys in 4210 bis. And yeah, but this is just that we wanted to raise this issue and see whether there is any feedback or support for this activity. Finally, it needs to be added to proof of possession as well as message protection. If CAM algorithms will be supported in CMS envelope data in key trans, then we have the support already covered with a change we did in CMP updates, switching to envelope data for transferring centrally generated keys.
So thank you for raising this topic. We had a short discussion when we were talking about chems at IETF 114, and it was observed that we needed a proof of possession mechanism to go with that. And I believe that Sean and Panos had agreed to put together a draft on that. Am I remembering that right? Go ahead, Sean.
Did I did agree to do that. I haven't done it yet.
Okay, so assuming that comes to happen quickly, then I think aligning this work and that work makes a lot of sense. Otherwise, we're soon going to be doing an update on 4210 bis, which seems kind of silly. So let's just make sure those go together as long as they go quickly.
Yeah. One question, Sean. Are you planning to support CAM-key proof of possession for PKCS10 and CRMF?
Good question, but I suspect it will depend on what we need.
Yeah, because PKCS10 sticks to self-signed, at least as of today. CRMF has more flexibility here.
Fair enough.
Basically, I think that was the reason CRMF was invented, was to be held in keys.
Yeah.
Right. So I don't know if we want to open up P10.
No, I don't. That seems painful. More pain than I really want to endure. So, yeah, we'll get to that. I mean, I know that we've already had some internal discussions amongst the authors about the motivations in which way we would do it, and I think there were some other people that sent me a message off list that said, "Hey, if you guys are going to do this, you also need to do this pop thing," and we noted that we'd had this discussion and they provided their input. So I'm sure it'll be a lively discussion as we figure out which one of the ways to go. But yeah, definitely on the thing. And I'm also hearing put this higher up on the priority list, and can do so.
Okay,
Yeah,
great.
I appreciate that, because I think that moving these together makes a whole lot more sense than doing a second update to 4210 bis.
Oh, completely agreed. I've been in your shoes before, and don't want to add any undue pain that's not required.
Awesome. All right. Any other comments about this? Okay. Is there any other business then? If not, we're going to wrap up 6 or 7 minutes early. Go ahead, Quinn. Quinn, you have to push the microphone at the top again. There you go. Go ahead, Quinn. Maybe you're locally muted because we're not hearing you.
Are you hearing me now? I'm sorry.
Yes, now we hear you.
Oh, thank you. Sorry about that. I heard that the wrap algorithm was used to send different symmetric keys to different recipients, right?
No, it's in order to get the same key to all of the recipients. So the CAM gives a pairwise, and then you wrap in that pairwise.
Okay. All right. So basically, we do different instances for everyone. Okay. All right. I got that.
Okay.
Yeah. Thank you.
Yep. All right. If that's it, we're going to wrap it up here. Thank you. I think this was a very productive hour, and we have action items for a couple document call for adoptions, and we'll be having that shortly. And I look forward to further list discussion on the topics that were raised by Mike. All right. Have a great day. Thank you.
Thank you.
Bye.
Thanks. Bye.